Hello, everyone, and welcome to another live stream by BCrowd. This is the first one that I'm doing in English, so I hope it all goes well. We have a very interesting topic today, and very interesting for many different reasons, including because there are opportunities that we have on BCrowd in this area of development. So just to start, I'd like to say hello to all that are following our transmission here. And please let us say hello on the comments and let us know where you're watching us from. And feel free, as always, to put your questions in the comments. And if we do have time, we will answer these questions during the live stream today. So today we're going to talk about firmware development, really coding at the core. And we have a very special guest with us today. Our guest is Agustín Derrégibus. He's the embedded engineering studio manager at Qubika, holds a bachelor degree in electronics engineering, a master's in embedded systems, and an MBA, and has over 15 years of experience in high-tech product development. So I would like to introduce Agustín to you all, and thank you, Agustín, for having the time to be with us here today and talk a little bit about firmware development.
Hi, Gaia. It's a pleasure to be here. Thanks for inviting me.
You're welcome. Thanks for coming. So to kick things off, I always like to start giving a lot of context to everyone that's watching us that maybe are not very familiar with the concept of firmware development. So I would like just to start. So if you could tell us a little bit about your background and how you got into firmware development in the first place.
Yeah, absolutely. Well, first of all, welcome to everyone that joined the live session. So I started. I studied electronics engineering, but from early on, I was kind of fascinated by programming. So what truly captivated me, I would say, was the intersection between hardware and software. Basically, this ability to bring physical devices to life through code. And so that passion led me to pursue a master's degree in electronic engineering, but specializing on embedded systems. And so, I began my career working on product development, particularly designing and programming for embedded hardware. Early on in my professional journey, I co-founded a startup focused on developing IoT products for basically remote monitoring and control for industrial applications. And more recently, for the past 3 years, I've been heading the embedded engineering studio at Qubika, as you mentioned, where I lead a team of about 120 firmware and embedded software engineers. I've been in this field for almost 20 years now. Although my role has evolved a little bit into management now, I now focus more on leading teams or guiding strategy than writing day-to-day code, but it's still my passion. Also in parallel, I've spent about 15 years as a university professor teaching computer architecture, embedded systems. So it's kind of my passion, I would say, and I would even say it's usually a passion for everyone that works on this field.
Amazing. And I think that's a very interesting background for our talk today, because not only you can give us a lot of insight on the coding side, you can also let us know, what do you look for in potential candidates that are going to work for you or with you at Kubika. And that's very interesting, actually, because we do have open positions at Kubika that are being worked by BCrowd. So we're going to talk about that a little bit later. But moving on in this context, I want to let people know a little bit more about firmware development. So for those unfamiliar, what exactly is firmware and how does it differ from traditional software, and where is most commonly used today?
Yeah, absolutely. And it's a question that gets asked a lot, right? Because you hear hardware, you hear software, but you not hear firmware that much. So to give a very simple explanation, basically firmware, you can see it as a specialized type of software that provides low-level control for a device-specific hardware. right? So in a way, it serves as the intermediary between hardware and higher level software. It's often stored in non-volatile memory like ROM or flash or EEPROM. And it's funny, but basically the term firmware originated around the 60s to describe that kind of software that was more permanent than regular software. And so that's why it has a firm and not the soft at the name. And I would say, like, unlike traditional software that runs on general purpose operating systems, you can find firmware. It's very closely connected to hardware, and it's often designed to be highly efficient and reliable. So we can talk about that a little bit later, but efficiency and reliability are some of the core aspects of firmware that perhaps makes it a little bit different to software. I'm not saying that software should not be reliable and efficient, right? But it's a particularly important thing to consider here. And yeah, you can find firmware in commonly embedded systems in general, like microcontrollers in different applications, wearable devices, appliances, medical devices, automotive systems, especially, of course, smart homes, IoT devices, and we can go afterwards in detail on some of those kind of applications. But that's kind of a high level overview of what firmware is about.
Interesting. Yeah, and I think that's very, very different. I don't work on this area, but I understand that it's probably very different. Like, you don't have an exact operating system to work with, and you have to usually coordinate with the different parts of hardware or the different types of memory. Maybe you can give us some examples and give us some real world use cases. Maybe mention some of the projects that you have developed lately in Qubika, so just people can get a better grasp of it.
Yeah, absolutely. So you can find firmware pretty much in every device that you use or see nowadays, other than a general purpose computer, right? Let me just tell you a few examples. You can find firmware in the automotive industry, right? So modern vehicles nowadays rely a lot on firmware for things like engine control units or ABS, the braking systems, or infotainment, or even ADAS, the advanced driver assistance systems. All of them rely on firmware in the vehicle. If you think about, consumer electronics, for example, everything from smart TVs to game consoles to, even kitchen appliances, you can find firmware in your microwave. So, it's kind of everywhere. Other applications, you can find it. You can see healthcare as an industry that has a lot of firmware associated with it. Think about pacemakers or insulin pumps, or all the diagnostics imaging equipment that is used in medicine. All of them have firmware that rely on them to work. On the industrial automation space, PLCs, robotics, even control panels, all of that, all the manufacturing process relies on firmware as well. You can find it a lot on the aerospace and defense industry as well. If you think about avionics and drones and satellite communication, all of those have firmware on them. And then perhaps an aspect that's not so much known, but it has to do with silicon development also, because firmware plays a key role in the bring up and validation of new silicon chips. It basically, enables chip functionalities such as power management or clock configuration or boot processes before the operating system takes over. So you could say that firmware is essential in the diagnostics also, and the updating things like microcode or configuration data in SoCs. So there's a lot of firmware involved, even on the CPUs or GPUs that you would consider are used for traditional software development, but there's a lot of firmware underneath of that to make all of that work, basically.
Amazing. And that's something else that has changed a little bit in the landscape of the industry lately, because mostly when I used to think of firmware, like many years ago, I guess our mind would naturally go to some of these appliances that you've mentioned, like microwaves or machines or some other kinds of stuff. But lately, like in the last 10 or so years, like there has been a big boom in Internet of Things, right? And that happens, and that's controlled by firmware as well. So my question is, how has this rise of IoT changed the firmware development landscape and the job market demands specifically? And what challenges or opportunities come with building firmware in the IoT era with so many connected devices?
Yeah, that is a great question, Kaya. So you're right. There's been a huge growth on the IoT space, but there are also other aspects that changed recently that impacted the world of firmware development. If we're going to talk about IoT to begin with, definitely it has expanded the field a lot. We have more connected devices, meaning more demand for robust, secure, efficient firmware, and this has definitely led to, increased job opportunities for firmware engineers who have a focus on things like connectivity or remote updates or security, right? There are also new challenges as well, because, you have on embedded systems or devices that usually rely on firmware, you have limited resources, either it be memory or processing power. You have network reliability issues. You have strong security requirements, because security has become a really important thing in firmware development. And so, developers need to consider all that when it comes to firmware, especially considering that one firmware image might be deployed to millions of devices, right? Now, I also said this is not limited to IoT, and this is because I've seen in the past years firmware, the relevance or the importance of firmware as a strategic lever within companies has really increased. It's no longer just a support function, but more of a core enabler of performance, security, energy efficiency, I would say there's a growing movement towards workload-specific silicon, right? As opposed to what happened before, that you had like a device that was kind of a general purpose or a specific purpose, but you wrote firmware for that device and that was it. And many different suppliers use that same hardware for different purposes. Nowadays, companies are moving beyond that, pursuing more like customized, more responsive hardware that can efficiently handle things like, I don't know, a real use case is AI workloads, for example. Okay. Now chips are being designed and firmware is being architected in a way that it needs to be integrated and optimized so that things like large language models or edge inference or computer vision can really work on those edge devices, on those local devices. And as I mentioned, companies are getting much more involved in the process of the actual silicon development. So it's not just a chip that does everything, but you have a lot of different chips customized and built for specific purposes. And of course, those specific chips need their specific firmware running them. And so there's a lot of work being done there. Definitely AI and the relevance that AI has achieved recently has a huge impact on how chips are being developed and how firmware is interacting with that hardware and providing support to higher level layers on the software development stack.
That's amazing, because, on the previous live streams that we've made, we have talked a lot about AI and it's impacting the several different technology areas. And maybe that was a little bit naive of my part, but I would think that today we wouldn't be talking about that so much. But it's interesting to observe that the growth of AI the last few years is impacting the world of firmware as well. So I would think of the chips, of course, but not the development exactly.
Usually people tend to think about AI as just software and that software layer, But in order to be able to optimize how hardware interacts, or basically be more efficient in different AI typical processes or things that are done with AI, then you need specific hardware to make it more efficient and to make it whether it is like processing efficiency or energy efficiency, but efficiency whatsoever. Yeah, the very low level layers of all this really play an important role. And yes, as I was saying before, there's a lot of development on the silicon stage on specific chips that are even CPUs right now have their own co-processor that handles those aspects of AI or machine learning acceleration, and they handle it on a different co-processor to make sure that that is made or run in the most efficient way. And so definitely firmware plays a key role in that process.
Amazing. Okay, so we have given a little context, and now I want to talk a little bit about careers in this area, and especially for people that are looking to start their careers in this area of firmware development or IoT or embedded systems. What are the technical and soft skills that are most valued in firmware-focused careers, and what kind of languages, tools, or environments are more common in firmware development?
Okay, yeah, that's a good question. So, I mean, you see people engaging in firmware development coming from different backgrounds, but mostly you'd see either electronic engineers or software or computer science engineers, right? Well, when you see electronic engineers get into the firmware field, they usually need to complement their programming skills. And when you see people from computer science or software science try to get involved into firmware, they usually need to complement their knowledge on computer architecture and how the hardware and the real world works. So, I mean, both careers and both fields are equally good. Although I would say usually electronics engineers tend to be more inclined towards firmware than computer science. But in any case, I mean, you definitely need to have a strong knowledge of low-level programming languages. C programming is still the most used by far language on embedded systems, on firmware development. C++ as well. I mean, so C, C++, both of them are used. Depending on how close to hardware you need to be, you might also need to know assembly language, which, I mean, is not something that most people would like to work with directly, but at least having a good understanding of assembly language. I mean, nowadays, I mean, you don't really write a lot of code in assembly language, but you might need to do it for very specific and very critical sections. But what's important about assembly is understanding it so you can debug, right? And you can understand the result of the compiled code and see what's going on there. So yeah, definitely low-level programming. Things like, I don't know, direct register access, bit manipulation, memory management, including, I don't know, concepts like stack, heap organization, memory mapped I/O, optimizing for limited resources. That's a big difference when it comes to embedded software or firmware development. You are not writing code that runs on a device that has, I don't know, gigabytes of RAM and doesn't care about whether you declare a bigger variable or a smaller variable. Like, you need to be really, really efficient with how you use your resources. So that's a kind of mindset that's different from standard software development. Real-time systems is also a thing to consider. I mean, there are a lot of applications on the firmware space that are really time critical, and there are certain aspects on how to handle that are a bit different. So that's important to keep in mind. You have a lot of interaction with the physical world that perhaps you're not so much used to on other software development fields. So you need to be able to interact with hardware interfaces like, I don't know, communications protocols. I think about, I don't know, I2C, SPI, UART, different GPIOs. even, I don't know, ADCs, converters. Like there are a lot of different interfaces that you use to interact with the real world, to get information from the world and to act on the world, knowing their electrical characteristics, their timing requirements, how to configure them and troubleshoot them, it's really, really important. Again, low-level knowledge of things like, I don't know, interrupt handling or polling-based communication, or how to like integrate with peripherals on embedded devices, all those kind of things. Then you definitely need to know how to debug, but not necessarily, or not only the standard way of debugging, but also debugging with tools like, I don't know, oscilloscopes or logic analyzers, or even like things like JTAG, which allows you to break into the hardware and analyze the execution of the code, but on the hardware itself, right? And you can see, because the fact that you're also interacting with the real world makes it necessary for you to be able to measure things in the real world while you are debugging or testing the code that you're writing. And so it's not just you and the computer, but it's also a piece of hardware somewhere that you need to be able to work with and debug and analyze. Then I would say, I mean, on the lowest levels of firmware development, you can either write code that's known as bare metal, which basically means that what you're writing is the only thing that will be running on the microcontroller or microprocessor. But there are a lot of different real-time operating systems that are used on embedded development. So knowing about different real-time operating systems, I mean, the most popular right now are, you could say, like FreeRTOS or Zephyr is becoming quite popular. There's sort of a layer that you can rely on to build a bit more robust, time-critical projects, especially when you have a team working on the same project. I would say also knowledge of CI/CD pipelines might be relevant, like understanding, I don't know, how to deploy, but also on the testing side, like things like unit testing or integration testing. There's, I don't know, usage of GitHub Actions or Jenkins or GitLab for, again, code deployment it's important. I wouldn't say it's a must, but depending on the organization and the size of the project and the size of the organization, that might really be important. So yeah, it's not the same to build a product that's a really small product with a small team, but a really complex product that might involve different teams on different domains of expertise. So definitely that's something to keep an eye on. And I would say those are the technical skills that I would consider the most relevant, right? Then you have, of course, everything has to do with soft skills. That's also important. I mean, having this mindset of like problem solving, debugging mindset, being very careful to detail, having good communication. I would say this is relevant for almost every work that you do. But I mean, when you have to collaborate with different team members and engineers on different fields, depending again on the kind of projects, you might need to interact with people that are designing either hardware or are designing a chip. If we're thinking about like silicon development, so you have a lot of digital design that's usually performed by other group of engineers. So that communication is really important. And let me see. Finally, I would say being able to adapt because it changes really fast, which is, I guess, true for all firmware software development in general. And patience, be very patient. You need to be patient because that sometimes, I mean, finding or debugging an issue on hardware can be frustrating and can take a lot of time. So being able to be methodical about it and patient and follow a process it's really important. So I would say about those things are the ones I would consider important.
Sounds great. Sounds like a lot of stuff as well. So hearing you speak a little bit about the inclinations of people that are usually joining this this area, and considering especially the like here at Big Crowd, we have a lot of people that are more to the software development spectrum. But also, there are a lot of people that are interested in low-level languages like C, C++, C Sharp, and so on, because most of people are in these programming competitions that usually perform better with this kind of languages. And my mind now goes somewhere like, so for people that like have these skills already, but they do have to complement a little bit on the physical side of things, as you mentioned. Is there anywhere that they could like find this kind of knowledge so they can start practicing when they don't have any experience? And there's another thing that we usually bring up in this conversation that are like, what kind of projects you can build to start your portfolio if you don't have any opportunity or you don't have any experience yet? And I tend to think at first that with firmware, that's a little more complicated. But also I remember like people doing projects using Arduinos or Raspberry Pis or something like that. Is that something that would be interesting for someone to show their knowledge and to start practicing to work with firmware and embedded systems?
Yeah, definitely. I mean, you mentioned what I was going to mention when you started like asking the question, because that's really, I mean, platforms like Arduino, Raspberry Pi, I mean, Raspberry Pi Pico, which is a smaller version of the Raspberry Pi, right? Even, I don't know, I'm a big fan of the ESP32. I had to work with it for a long while, so I kind of like it a little bit. But there are a lot of different hardware development boards that can be acquired for a relatively low cost, and that are really easy to get, and that have a very, I would say, beginner friendly ecosystem, right? Where you can find a lot of documentation, a large community of people contributing to the project or the platform. So yeah, I mean, anyone that is currently not so familiar with firmware development or embedded software, embedded systems development in general, I would advise them to get started with one of those. I mean, if they are coming from the software world, they will definitely know how to program. It's just about adapting to a lower level language to feel comfortable with things like, I don't know, being closer to hardware, or being able, or having to take care of things that you usually don't care about when you write higher level software, right? I don't know. I think about usually things like memory management, for example. That's something that's you need to be more careful when you're dealing with embedded systems than you do when you do standard software, right? But I will definitely get started with that. I mean, learn C fundamentals and get some of these development boards and start playing with them. Yeah, definitely that's a really good way to start.
Good. And it's also fun, right? So like people can like create some, I don't know, home automation projects or some stuff like that. That's probably going to be fun, something to impress your friends or something like that, and also get some knowledge on this field. So yeah, really interesting, really good way to start. Okay, so I have a few more questions for Agustín, but I just want to remember everyone that's watching us. So if you want, or if you have any questions about that, about firmware development or embedded systems, please leave them in the comments. If English is not your first language, because I do know that we do have a lot of members in our community from Brazil or Latin America, and if you want to leave your question in Portuguese or Spanish, we'll find a way to bring it to discussion. And if you already have done any fun projects with Arduino or Raspberry Pi or something like that, let us know as well, because it will be fun to know. So Agustín, on my next question, we have mentioned a little bit how this field of firmware development and IoT and embedded systems is like growing and changing really fast in the last few years with AI and some other developments that the field has been through. So my question is, what trends are coming, or what are you noticing that are changing in this field, and what should we keep an eye that's gonna be big in firmware development and IoT in the future in the next few years or so?
That's a great question, because as we discussed before, a lot of things are changing, and let me see. I would say, I mean, there's been an increased growth. There's been growth on edge computing, for example. So moving intelligence closer to the data source, which basically allows for lower latency and reduced bandwidth usage, even greater autonomy for those IoT systems. I mean, there's been a lot of growth there in the edge computing, and that requires firmware to support real-time interfaces and local decision making, right? I've also seen, and then we talked about this a few minutes ago, AI and machine learning inference capabilities at the edge, right? And so devices are, I mean, increasingly running lightweight AI models, for example, on locally, and not on a server. And so that brings a lot of demand for, I mean, firmware that is capable of supporting AI accelerators, or managing memory more efficiently, or, as I said before, interfacing with specialized silicon built specifically for that kind of purposes. There's also been an increase in the importance of cybersecurity, because as devices become more interconnected and growing number, then they become also the primary sources of attack, right? And things like secure boot or trusted execution environments, being able to patch vulnerabilities with OTA updates, or on the air updates, is becoming more important as day by day. I've seen more adoption of real-time operating systems. I mean, I mentioned also projects like Zephyr, RTOS. It's gaining a lot of traction because, I mean, it's modular, it has a strong community support, and in a way, it's vendor neutral in terms of architecture. So that kind of speeds up the whole development process, and I mean, it allows for a lot of flexibility. And let me see. I would say, well, I mentioned OTA updates. Yeah, I mean, it's always been the case, but it's becoming increasingly important. They need to be able to keep firmware updated, either because of security reasons or because of functionality reasons. But there's a whole field there of work on updates for firmware, and being able to do modular updates, to have rollback mechanisms to be sure that you don't break a device, have fail-safe recovery mechanisms. So all the dynamic updates for firmware, which is funny because we started this conversation saying that firmware was more permanent than software, and hence the word firmware. But that frontier between firmware and software is starting to fade in a way, right? Because firmware is no longer so permanent, but it's something that's constantly getting updated as, I don't know, applications or functionalities evolve. So that's a little bit funny. I mean, the term firmware remained, but it's not so firm anymore. It changes a lot.
That's a funny change. Yeah, but yeah, I guess with all the connections and all the stuff, it's pretty much what you mentioned, right? Like, things need to be updated. Security reasons probably make those a lot. It's really shocking to see sometimes what kind of hacks people do with like hardware devices and stuff like that. So it's really a growing concern, and I understand that there's this need for patches and updates that happen more often. And speaking of that, I would like to ask you a little bit about the projects that you're currently working at Qubika. So I would like you to tell us a little bit more about Qubika to start, and then if you could mention some of the projects that you have been working lately, that would be really fun for our community to know better about the company.
Yeah, absolutely. So I mean, to start with, Qubika is a software development service company. So we have different areas of expertise in which we help our clients develop their different projects. And those areas are divided into studios. So we have different studios specializing on different areas of expertise. I lead the area, the studio that's called the Embedded Engineering Studio. So we work on everything that's related to low-level firmware, embedded software development, and high tech in general, right? But yeah, we do have a lot of different areas of expertise, like I mean, engineering, mobile development, QA, even design, and of course data and AI, which has become increasingly important recently. But going to what we are working on our studio, we are doing a lot of work on pre-silicon and post-silicon development, and I will dig deeper into that in just a minute. We do firmware development in general, IoT device development, sister performance optimization, testing, verification, validation, and of course technical consultancy and advisory. But everything that has to do with low level or embedded software or any specific device, then we take care of that within Qubika. I would say the most important project or thing we're working on is we partner with one of the largest semiconductor companies in the world, and our team is working on firmware development for both current and future CPU and GPU models. And we're working on really cool stuff. Things like, I don't know, firmware development for hardware accelerators for AI. I mentioned that before, but we're working exactly on that. So those pieces of hardware that are built within the silicon to make sure that AI operations are executed and run more efficiently, we are working on that firmware for those silicon AI accelerators. We're working on things like power management optimization, which is also really important. I mean, with mobile devices and even not necessarily mobile devices, but power consumption in general is really important because of the increasing awareness of environmental things, right? We are working on bootloaders as well as developing, and this is really interesting as well. We are developing, since we're working a lot on pre-silicon, which means we are writing firmware for hardware that does not physically yet exist, then we need to have means to test the firmware that we write, right? And so, and that's a process, by the way, that may take years. Like you might be working for firmware for a device for years before the device is actually physically available, so you can actually test the code that you wrote. And so in order to be able to parallelize those two things, like the physical chip design and the firmware development for that future chip, you need to develop tools. And we're also working on the development of those tools, which I would say don't strictly fall under the embedded software category because it's more general purpose software. But from a skills point of view, of the people that's working on the development of those tools, really need to have a strong understanding of computer architecture and low-level programming, so they can build the machine that will eventually allow to simulate the behavior of a chip. So we're working a lot on that as well, on the actual platform or software tool that's used on the development of the firmware and the pre-silicon stage. And you mentioned that before as well. We're growing fast. We have a team of 120 people right now working on this kind of projects. And by the way, I focused a lot on pre-silicon development and chips. We, of course, work on several different IoT projects. Healthcare is a strong vertical for Qubika. So we are working on different projects related to either wearable devices or medical devices on the healthcare space that do require a lot of software, but also require a lot of firmware as well. And we've had, I mean, interesting projects on different areas. I don't know, just to name one that I can remember now. We worked on a gateway that basically handles lighting for movie sets or big theaters. So we've worked on the development of the embedded software for that device. It's really interesting because it's the device that's used, for example, on the Mission Impossible set for the movie. So that device is used there for all the lighting organization, like the orchestration of all the lighting on the set. And we've worked on the embedded software for that device. So, I mean, anything that has to do with low level, anything that has to do with some kind of interaction with hardware, we're working on that. And by the way, we're growing. We're growing really fast, and we're hiring, and your B-Crowd is helping with that as well. So hopefully, after this conversation, we might spark interest from some of the people that's listening.
Yeah, I just actually put out this banner here about this position that we have open at Qubika. That's a mid-level C++ development engineer. So if anyone has had a spark of interest in this area of firmware development and are familiar with C++ development, well, let us know. Access this link and apply for this position. Maybe you can be working with Agustín in a few months or years. I don't know. Okay, so we also have some questions here, Agustín, from our audience. So the first one, Ariel asks us, are there any communities for beginners that you would recommend for people that are starting in firmware development?
That's a good question. I mean, there are a lot of different communities. I mean, you can find a community specifically on embedded software on Reddit. I think it's, I don't remember exactly the name, but if you look for it, you'll find on Reddit there are several communities that I mean share their knowledge and passion for embedded and firmware development. Then there's a community, I think, in Stack Overflow as well, that you can also join and be a part of. This is not necessarily like community, but thinking about ways of learning. I mean, you have different courses on known platforms. I don't know, like Coursera or Udemy or Udacity that focus specifically on the skills that are required for embedded software development. So that's a nice starting point as well, I think.
Great. If I might also add a little something, usually you can look at Meetup, and I'm sure there are going to be some embedded systems or C++ communities on Meetup that you can find. And some other suggestion, and maybe you can tell me if I'm right about this, Agustín. Maybe you can look for Fab Labs or hacker clubs. I know that here in São Paulo, for example, there's one that's called Garoa Hacker Club. And I'm pretty sure that people work a lot with chips and stuff like that there. So usually these people that are more into hacking usually like to mess with this stuff. So maybe there's something to look for as well.
Yeah, absolutely.
Great. And there's another question. This is very specific. So let's see. You mentioned a little bit about that in the talk before. So Andrea asks us to if you could tell us a little bit about edge computing and applications with TinyML, and what are the technical skills required for that?
Yeah, that's a good question, and it basically combines two areas of expertise that are merging a lot in the embedded space, right? What is embedded software, firmware development, and the knowledge on data, right? And the combination of those two. I mean, besides what I mentioned before, which applies also to these kind of applications, I mean, knowledge of C++ programming languages and familiarity with real-time operating systems, knowing certain platforms, you should also have a good understanding of things like, I don't know, unsupervised and supervised learning, right? Like knowledge on very specific things that are related to data, and AI, decision trees, neural networks, SVMs, for example, just to name a few. It would definitely help knowing about frameworks like TensorFlow or TensorFlow Lite, which is the one used for more constrained devices, or light versions of PyTorch, for example, which there are. So I would say it's a really interesting field. It's a growing field, and what you should add on top of that general knowledge for embedded software and firmware development is that specific knowledge of some tools that, as I mentioned before, things like TensorFlow, PyTorch, and also the theoretical knowledge of some of the more scientific, so to speak, aspects of AI and machine learning that you should know. But there are definitely a lot of opportunities there, and there will be even more opportunities for this kind of expertise in the future. That's going to be growing really, really fast.
Great, amazing. So we're reaching the end of this talk, so we have 13 minutes left. So if there's any question, please bring them in the comments right now. But I do have a last question for you, Agustin. And this is the question that I usually like to end this kinds of conversation. So again, focused on people that are curious about firmware. Maybe they're got more interesting hearing you speak about it, but they don't know where to start or unsure or where to begin. What advice would you give to someone that is starting right now? So what kind of advice would you like to have received when you were starting out? I don't know. What would you bring for people that are starting on this field right now?
Yeah, that's a good question. I mean, assuming that we're talking about people who have relatively short experience or no experience at all with this kind of things and firmware development, and we kind of touched this previously, but I would definitely recommend starting with some small microcontroller platform and acquiring something like an Arduino or a Raspberry Pi Pico or ESP32 or STM32 based development boards. As I mentioned before, they are really low cost. They are easy to find. They're easy to buy. And I always like to highlight that fact that you have a very strong community. There's a lot of documentation, so you will be able to learn by. I mean, firmware is something that you learn a lot by doing, and so you can read a lot, and that's okay. But you need to eventually get your hands on some kind of physical device and start doing things. So I would definitely advise anyone who wants to get started with this to get your hands into one of this kind of devices and start reading documentation. Start with simple projects like, I don't know, start blinking a LED or integrating a temperature sensor or controlling a motor, or things like very basic stuff that will allow you to feel comfortable, especially for those who do not come from a field of hardware. Usually that's the case for, I don't know, computer engineers or software engineers, getting to feel comfortable around physical hardware devices. And you would need, of course, to read a lot of data sheets and being able to navigate through hardware manuals, which is not something that everyone's used to. But definitely, I would say get your hands on some device and start working with that, because nothing beats learning by doing in firmware. That's for sure. And so don't be afraid to break stuff, burn stuff, blow up stuff. That's how you learn.
Amazing. Wow, that's incredible advice. We haven't had any more questions, so I would like to thank you very much, Agustin, for being available here to talk to us about this growing field in technology. I'm very happy to have you here, and I think that it's been very, very important for our community to learn more about that. I have posted already, and I posted now on the links as well, the open position that we have with Qubika. So that's it. I would like to thank you. And if you have any last message that you would like to give to our community, or where they can find more about Qubika or you, or reach out to know more about this area, feel free to give your final message.
Well, yeah, and I mean, we have a lot of information on our website, qubika.com, and there's a section dedicated to embedded, our work in the embedded field and the high-tech field. So I welcome everyone who wants to see a little bit more about the kind of things we're doing. You can find it there. And yeah, it's been a pleasure, Caio. Thanks for having me.
You're welcome. Thank you. And thank you all for joining us today and watching this talk that we have had. I hope it was an interesting topic for you, and that you've felt the spark of starting to work with some chips and devices and learn more about firmware development. I would also ask you to join our community on Discord and let us know of the projects that you're starting, or any doubts that you have, or what else you have been doing. Discuss with our community there, and check the link that I put on the comments to apply for the position that we have open with Qubika. So keep in touch with our newsletters and social media to know about the next opportunities of live streams that we're going to have. And I hope to see you in another one soon. Thank you all. Thank you, Agustín. Bye-bye, everyone.
Thank you. Goodbye.